All right, so today is week 2, day 3. Is it day 3? That makes it today's Wednesday, right? Because I didn't take out the recycling today. So day 3, part 1. This is not going to get confusing at all. Um, and yesterday we kind of switched some things around. Today we're going to do the thing I wanted to do yesterday, which is my bike race simulation, which is always a lot of fun because I typically always get it to work, and it usually takes up the entire time. We're going to see a simulation in effect. We're going to just pretty much program some randomness. We're going to give some rules for how long it can run, and we're going to provide some parameters of how things progress up to the end, and then we're going to see which one finished first. It doesn't have to be a bike race. It could be any kind of race, but I like to use bike because we can make a concrete object out of a bike. And so we can use classes. We can have a game managing class. And I say that because tonight's homework, you're going to have your currency converter and to finish tic-tac-toe. And we'll be able to address any questions you have about tic-tac-toe, especially during lab. We can just sit there and go through all of it if you want. And the currency converter is a challenge, but I think after we've had a couple of days of object-oriented programming, it's not going to be too weird. So before we jump into the bike race simulation, though, I want to make a good point about collaboration between classes. Because classes are very rarely ever going to just be by themselves in your program. And I mean, not to say that they won't. You'll have some classes that are just, maybe data classes, or like they're a leaf node or something, and so they don't directly have any dependencies. And I will add on, if this winds up making complete sense and you're really strong on this, we're going to have zero problems with databases next week. And I said this yesterday, but the stronger that you are, that more comfortable you feel with this, the more comfortable you'll feel with databases and relating data next week. Because it's pretty much a one-to-one in how they work together, especially in our web applications. So this right here, so there's 3 types of collaborations and relationships. There's dependency, there's association, and inheritance. And I kind of just distilled down this whole article in your reading, so like I didn't intend for you to read the whole thing. I could just talk over this, but the way also another way that you can plan it is to think like, how is my data going to be related? Does element A have a direct relationship with element B? Okay, so if A requires B, does B require A, or is B just like, I'm just hanging out here? Like when you think of like a baseball player's relationship to their baseball bat, what does that relationship look like from the perspective of the baseball bat? Right. But the baseball player, like that it is a hard dependency, but the baseball player uses the baseball bat. The baseball bat doesn't use the player. So when you think like from a programming standpoint, how you would code that up, would you make a baseball bat and then give it a player, or would you make a player and give it a baseball bat? So that's how I want you to think about your programs, is that who is or which is using which. And when I say like give it, like air quotes here, you need to give it a baseball bat. Typically, all I really mean is you just create an instance of a baseball bat class somewhere in the baseball player class, like in a method or in a init or something like that, so that it can have one accessible on its data and methods on self. You pretty much just make it a variable on self, and that's what I mean by you give it to it. I don't mean anything magical about giving it to it. You don't like cast some spell on your computer or something. You just say, I want to set self.something equal to baseball bat instance. And then now throughout, if you do that in your init, then all throughout your methods will have access to self.baseballbat and all of the things that are in baseball bat, like if it had a cork in it, or what material it was, or if it had tar on it, those kinds of things. So you could say like self.baseballbat has cork. Like all of that will be available to that player. So this is a good way to kind of see like how this could be related. And this might be a little bit of an extreme example, But it's an ordered list, 1, 2, 3, 4. So we want to read these in a programmatic method. So that the program tells the game controller to move north. So the program here would be like that def main, like your that's the overall program that when you run the program, like what's that global namespace? So we're gonna so when you think about how that would be, okay, so we need to make a game controller. So the game controller is like its own class. So the program has a relationship to the game controller, and the program will say, "Hey, game controller, move north." So the game controller then will tell the player to leave heading north. Now the player could be another class, or it could be another object that is an instance of a class that's on the game controller. Now we might be halfway through with the state of a game, so we already have a bunch of players, we probably already have a bunch of dragons and stuff, but if the person issues a command to move north, then the program will tell the controller to tell the player to move north. Then the player tells its current location. Now this is really going to make a lot more sense when we get through today's programming example, is that the player will say, okay, I have a location. Maybe that's self.location. And that's, or maybe it's even a method, right? That messes with where its location. It could be an X and a Y coordinate. It says to move north. Well, okay, here's a pop quiz from yesterday. If you want it, and now think of it as a grid. Now think if you have X and Y's and you're all starting to panic again. But think if you had a grid and you wanted to tell a player to move to the spot to the north of them. Would we be able to use this? This is a true-false question. Would we be able to use the same method that we used yesterday in the class example where we were using the grid and we wanted to find the spot up from where that current node was? Same column, one row before. So that could be the low-level logic to say, hey, the player tells its current location, I want to move up one spot to that way. So it's sort of passing down these pieces of information. And then there's a room maybe in that spot. And then asks each of its exits, do you head north? And so that's pretty much saying that the player says, I want to move north in its location method. Now, that's going to see that the player's in a room, and it's going to say, can you move north? It's going to provide that validation. Now, of course, we didn't code up this game, so we don't know all the rules and regulations of it. But just to show that these are all different classes that are going to be working together. And like I said, this one's probably a little bit of an extreme example. Our bike race is a little bit more scaled back. Like yes, in the bike race, we have a race class, we have a bike class, and we could take it much more fine-grained. We could have a racer, like a person class. We could have bike upgrades class. We could have, we could even put all the components on the bike, but we don't because that would take way too long. Instead, we just have some random modifier that says if they go fast or if they go slow. But we could abstract that out to be like upgrades. Say we just make it a number, like how many upgrades do they have? This person has 5 upgrades on their bike. Okay, well, maybe they can go super fast now. We just mess with that random modifier so that it never goes below like 0.75. So that they won't slow down ever because they have the speed modifier. Anyways, so let's get into the different types of relationships. Here is the diagram. I didn't put this into your reading. I don't know if I want to do this. So, yeah, I mean, we can look at this. It's a little weird because it's using kind of strange terminology. But the drawing controller to the drawing is kind of like the baseball player to the bat. So you can kind of think of the drawing controller to the drawing as a uses. It's the dependency. The drawing to the shape is a has a, and then the rectangle, ellipse, and line is a. Because that's another thing is inheritance, is a. So uses, has a, and is a. Sounds like we're talking a different language right now, doesn't it? Uses, has a, and is a. It does kind of sound like gibberish when you say it like that. But if I was to say that Kevin uses a lawnmower, Zach has a flower, and John is a student, that doesn't sound so crazy now. So we don't necessarily need to get too much into inheritance, although it's probably one of the most common. We're going to see a lot of uses and has today. So there's more detail of what it goes into here, and of course inheritance is just like okay, you have a desk, now you have a small desk. Now inheritance can best be summed up. Remember when we had sword and then we had fire sword, and we said that fire sword, and we put the sword in parentheses next to the class name. That was us essentially making a baby, like an inherited copy of sword, and saying we have a fire sword. So that way when we looked at that relationship, we could say that a fire sword is a sword. So like when you use inheritance like that, it is a way for you to explain your objects as smaller, more detailed versions of their parents, just like us, right? So when you have a fire sword is a sword. A fire sword doesn't use a sword or has a sword. It is a sword. And so that means that it inherits all of the properties from the sword that's above it. Let's see, what else do we have? Then you have the player or the fighter. Let's see, the fighter has a sword. Because and it doesn't really do anything to the sword. It uses it, and it uses it. I think that's right. Is that the right way to use that? Now I'm like arguing with myself. What's that?
The sword of the player has a sword, but also uses the sword.
Well, I think when it says it uses it, that says that
it needs
it's
it in order to complete the function.
Well, no, I think when it says that it uses it is that it like tells it to do something. Versus, shoot, now I'm calling into question my explanation of this. Let's read it out loud. Kind of relationship can be thought of as a uses relationship. This is dependency, and represents a temporary relationship between roles in which one role uses an object or objects of another role. Okay, so that sounds kind of like how somebody would have a sword. So a fighter uses a sword. Now let's take a look at the has-a now. Now, unlike a dependency, an association is a permanent relationship. The object knows the object or objects it is associated with. The association relationship can be thought, that's a typo, of as a has-a, as in the drawing controller has a drawing. The drawing has 0 or 1 selected shapes. Or a drawing has a number of shapes. So it's almost like it's both. Right? Well, it's not temporary. Oh, I see. So has-a means that it absolutely requires it to be there. So I guess in our case,
that would sound more like a dependency. Well,
I would agree. I would agree when you think of like a strong dependency. This means that the object can collaborate with the objects it is associated with whenever it needs to. In code, this is implemented in the same way as any other knows style responsibility. A field is used blah, 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 blah. We don't need to get into the details. I wanted to kind of keep you from that. Take a sip of coffee here. Yeah, the characteristic is that it is temporary. In the example above, the drawing controller only knows about the shape after having asked the drawing for the selected shape, and then forgets about it so it says that the drawing controller uses a shape. Okay. So our fighter has a sword, and if that sword had some properties of it, like a gem inlay or something like that, that means that the player would indirectly have a temporary relationship with something on that sword. I'm not a fan of how that's drawn out. The reason why this is causing me pause here is because in database programming, I treat almost everything as a has-a. Like when we get into actually relating data, things are either has a or belongs to. And that's because, so I don't really like to think about things as being temporary. Um, like all temporary really is just a permanence that broke its promise. So what we've got, like think of it from a web programming standpoint. A user on Twitter can go on Twitter and write tweets, right? Now, from a database perspective, that means that a user has many tweets. Like I, Joel Taddy, have probably tweeted about 4,000 times. It was really a surprise to me when I saw that the other day. I was like, did I really tweet 4,000 times? Like, that's a lot. But when you think about a individual tweet in relationship to me, the user, that is a belongs to. So that tweet belongs to me and nobody else. But I have a lot of tweets. When that relationship is kind of understood, then that's really all we need to know. So I think that that's why dependency is throwing me for a loop here, because I don't really use them very much. I feel like temporary relationships, like maybe not. Maybe they're used more in game programming, and I just haven't dug that deep into game programming. But associations are really what we're going to be digging into. And then there's also has many, or not has many. We have many to many, where you have two has manys on both sides, which we're not going to talk about today, but they do exist. So yeah, association and inheritance are going to be what we see mostly. So before we get jumping into the bike race, because we're probably just going to go right into lunch. By the way, Zach, sorry you missed noodles. It was amazing. Was it amazing? Noodles were amazing. Did you? Oh, we could do Noodle Tuesday. That might be cool. Did you have it for dinner or lunch today? Nice. He was the only one who wasn't able to eat all of his noodles. So. Not that it was a contest or anything, but Kevin and I totally won. All right. Any questions about tic-tac-toe? By the way, I got your message last night, Zach. Tic-tac-toe is a 2-part assignment. So I probably should have told you that before I went to bed, but I didn't. But the part 1 is really just to get the user interface set up so that I can say I want to put a spot here. And if you can get a spot to show up and then it redraws the board, you're done with last night. Any work you did more than that was digging into tonight's. So tonight's homework for tic-tac-toe is going to be move validation, to say if a user tries to go into a spot that's already taken up, they can't go there. Let them retake their turn. Or you could be a jerk about it and not let them take their turn. Let them kind of suffer. And also, you're going to have to do win condition validation. So every turn is going to have to check to see if there's a win. Now, I've taken it easy on all of you, is that for tonight, the normal mode is a win in a vertical or horizontal way. Hard mode is diagonal. So if you want to kind of take it upon yourself to do that extra coding, go right ahead, but it's not part of the base requirements for this. If you can get it to show horizontal and vertical win conditions, then you're good. I think that's all I wanted to say about that. Currency Converter is a program that is completely object-oriented, and it's not a very big program, but it's one that will cause you to kind of bend your mind a little bit. And it uses a lot of, well, I think it's not necessarily always going to be using the operator overloading, but essentially what you're doing is you create a money object. You create it like a class called money. You provide it an amount, and you provide it a symbol like US dollars or Japanese yen or something. And then you should be able to convert that through a method or something, like say to USD or whatever. You should be able to convert that and see it in different currencies that you have pre-programmed. So it should convert itself to a type of currency. And it's not too bad when you deal with US dollars, but when you convert currency across from one to the other, You either need to hard code it, which is incredibly difficult, or you need to use a common base. So it's like you're going to look up all of your currency values based on the US dollar. So converting a US dollar to a US dollar is 1. You multiply it by 1. And every cohort, this is different. But another, like converting a US dollar to Bitcoin, right? That's like what, 1,000? Or 1/1,000th or 1/1,000,000th or something like that. So that's saying that if you want to have $1, you need to multiply it by 1/1,000,000th, and you'll get a amount of Bitcoin as you have with $1 to a Bitcoin. Now, if you want to convert a Bitcoin to a Japanese yen, you either need to hard code that, which you are not allowed to do, or you need to convert first the Bitcoin to US dollars and then convert that US dollars to JPY, because if all of your conversion rates are through US dollars, you have to do that extra math step. So that's what makes tonight's assignment difficult. If you really want to add some finesse, you can use operator overloading, which is a really cool way of saying, like, I have a money object, and then I'm going to say I'm going to plus another money object, like just math, right? Plus another money object. So I have 5 US dollars and 10 euros. It should convert the euros to US dollars, add the amounts, give you a new money object that is however many US dollars that is. So it does conversion and math in one step. So it's a fun one. All right, but what we're going to talk about now is a simulation. And so let's go ahead and get started with that. Let's close out of Game of Life, never to be seen again. And I am in my Carolina Code School Notes Week 2 directory. You'll notice that I never close out of my terminal. I always just leave my terminal open. I think that as you progress in your development career, your terminal just stays open all the time, and you'll see that. So what we're going to do is we're going to get started, and I'm going to create a day 3 file in my week 2 directory. So it's going to be day 3. Zach, can you get that door for me?
Yep.
Day 3 bike sim.py. You should have slammed it and then like give a really, really dirty look. Day 3 bike sim is the name of my file. Doesn't really matter what it's called, just as long as it starts with day 3. All right. And at the very beginning of this file, I want to kind of organize my thoughts. That's what I usually always do if I start something new. Is that I want to make a bike race, okay? And I want to see like what the actors of this bike race is going to be. We're going to have a bike, and we're going to have a race. This is kind of looking a little silly now. So let's say actors. Actors is just a way of saying what are my classes probably going to be. What are going to be the responsibilities of a bike? So what can a bike do? A bike can know its position. I want a bike, maybe they have like a GPS, right? It knows how far along they are in the race. A bike can know its position, and it can move its position forward. Let's see, what else can it do? I'll make a new line here. Whoa. A bike can also speed up, slow down, and I think that's about all we want the bike to do. We want the bike to know where it's at, we want it to move itself forward, we want it to speed up, and we want it to slow down. And maybe we can put in some speed modifier. We'll see, though. We're not going to put that in initially. When we realize that the bike race is really boring and stupid, and that the first bike always crosses the finish line, then we'll go and we'll put a speed modifier in there so we can see it look a little different. All right. Now the race. The race should have many bikes. So the race will make a bike, or the race will eventually, when we create a race, it will then create its own bikes. the race should know how long a race is. Should know a finish line. Because that finish line is going to be what we cross-reference to the bike's location. So the bikes will be able to report where they are. And so all we really will need to do is check to see, is a bike farther than the finish line? Has it crossed the finish line? How many bikes? How long a race is? A race needs to advance all bikes. Now, of course, the bikes do the advancement, but a race should be able to say, hey, bikes, go move yourselves forward one. And a race should also be able to declare a winner. So that's the entire simulation in a nutshell. Don't worry, there's not going to be any cells or anything coming alive today. So this is going to be a very straight line. A race is just going to be a straight line. Think of it like a sprint, like when you're a kid and you like challenge the neighbors to a bike race. People don't do that anymore. Why don't people do that anymore? We need to have a bike race.
Saddest realization for me was like locating where your friends are. You just like either looked out the window and saw like 20 bikes tossing along. You're like, that's where I'm going. Now it's like you don't really knock on your friend's door and ask if Jimmy can come out and play. You just call it.
Yeah.
Don't even call. Just yeah.
Yeah, calling is so weird now, right? Like, why do people call each other even?
Calling is concerning. Usually means something bad.
Or someone wants to sell you something.
In my case, yeah, Carol Sadisco, the old lady that had my phone. I don't know why, but I get like 100 calls a day. It's super annoying.
Nice. That's what you need to do right before you get a phone, or before you get a new phone, or maybe even after. Just go sign up for a bunch of stuff, and then when they release that number, somebody else will pick it up, and that's in those databases for a very long time.
Companies are evolving. I get text messages. It's
You want Craigslist, place an ad, selling a nice car really cheap, put somebody's phone number on it.
Yes. I've got a 2012 Toyota Corolla, $700 or best offer.
willing to trade for a peanut butter jelly sandwich.
You're guaranteed 100% to get offers to trade for guns. People like to trade their guns on Craigslist. Let me just say that. You can like sell like a kiddie pool and they'll be like, I don't have $25, but I got this gun. I got an old shotgun. Kiddie pool for a shotgun? That's Craigslist for you, though. No, it's actually, I think it's more like a car thing. Like if you want to sell a car on Craigslist, someone will always show up with a bunch of guns and try to trade them for the car.
We'll
like-
also have 6 people saying they're going to show up.
Ask Lee about that sometime, about the couch we have here. Like, I think she put a couch up, and it was a clean couch, and there's a picture of it in a business space. I think she had like 10 people say they were going to come get it, like just one after the other. And finally, she just put up the ad, like instead of dealing with people, she said, "It's sitting here. If you're going to get it, just come get it." You know, like I'm not going to talk to anybody about this anymore. I sold a guitar on Craigslist. Great experience. Fantastic experience. Which is probably not the norm, but it was a great experience.
Did you go meet him at the Guitar Center?
I did not. I met him at
That's very common.
I met him at my apartment complex. I was selling a bass and a large amp, which essentially I pretty much got what I paid for that bass, but the amp was free for him. So I was like, and the dude just showed up with $800 in cash, 8 $100 bills. And then I saw it on Craigslist the next day for $1,000. And it wasn't the amp bass; it was just the bass for $1,000. I was like, he didn't need the money. I needed to pay rent that day because I met him at the apartment complex in the front building. I pretty much took the $800 and was like, "Here, this is yours now. Thank you for waiting for it." And he can sit on that. So, anyways, all right, sorry. But somebody needs to tell Maddie that we get back on track at 9:45 when she's watching these notes. Timestamp 9:45. Joel starts rambling about stuff. Sorry, gotta keep focused here. Having focus issues today. All right, so we need to get started. Usually, what I'll do is I'll just start sketching some stuff out. Now, the bike, we've I think we've got everything we need to do here. Like we have some data about it. We have the position, which is going to be a data point, so self.location. We want to move the position forward. So if I have location and I want to move that forward, what do you think I would want to do to move it forward? Like, how would you interpret that? What's that? Be a method, but what do you want to do to the data that would move my bike forward? My location is 0 at the start, and the finish line is 100.
Plus something.
Just plus 1, yeah, plus something, plus 1, plus 100. We don't know what we want to plus yet, but see, we're like interpreting how we can modify this data to have the effect that we've moved something forward in our simulation. We've progressed it. So I've got my position, which is going to start it at 0. I need to move that position forward, which will just increase by 1. But we also have this idea that there's speed. So I'm guessing that the position is going to take the speed into account. So, for example, if I have a speed of currently 1, that means that I probably want to move the position ahead 1 spot. If I have a speed of 14, which is really fast, maybe not 14 miles an hour, maybe I want to move that position ahead 14. So we'll use speed as a way of telling the advancement method how far we want to go ahead. And when we abstract that out to its own little method, then we can put some cool modifiers on it. We can put randomness, we can have like a speed modifier, but we're not going to worry about that yet. And the slow down would pretty much just make your speed go down. So our speed. So we know we also now need to have a data point that is our speed and a position, and then we move the position forward. So I pretty much just told you everything that we want to do here. So we should be able to code this out in maybe 2 methods. So if I make a bike class, I want to be able to create inside of my init. I have its position. We'll say self.position is equal to 0. And we have self.speed is equal to 0. Okay, that was easy. Now we want to be able to move we want to set the speed. We want to speed up. So let's say maybe we def speed underscore speed up. And how would I indicate that I'm speeding up in this method? Self.speed what? Randomize it? Not right now. Let's save random until this gets boring and not fun. Right now, I want to make sure it's predictable. It's doing exactly what I want it to do. Plus equals 1. And if speeding up sets our speed to plus equals 1, if I have slow down, self.speed maybe minus equals 1. Now I can tell you right now that that's going to cause a problem because I've done this enough. And the first time I did this, I realized that this problem existed. Can anybody see a problem, by the way, with doing this? And what would happen if you go negative? You go backwards. We don't want to go backwards. Nobody goes backwards in a race. Sure. Yeah. Now,
Can we do that at the end like we were doing yesterday?
yeah, we're not going to do that yet. Yeah, we're not going to worry about that right now. Because right now, this is enough information for a bike to go forward enough. So we can say, like, oh, we don't have the information to move forward. And so let's make a method that def move, or let's call it advance, because we don't know where it's going to go. So if I've got position and I've got speed, and I want to move my position based on its speed, so if it's currently going 2, I want to move it ahead 2 ticks. How would I do here? Like, how would I do that? Self.position plus equals self.speed. Yep, this is a great start. And I say great start is that this is like 90% of what a bike will do in this race. We're just coding out some very basic skeletal parameters of what this bike can do. And now, so what's going to happen is that the race is going to be sort of that drawing controller we were talking about earlier here in the web page. Is that you've got a drawing controller and you've got a drawing where the bike is going to be the drawing, and then the race is going to be the drawing controller. So, sorry, that was a little bit weird, but the bike we can refer to as like think of it like a tree, right? The bike is the leaf. It doesn't go any farther down than leaf right now. So it doesn't have any dependencies. All a bike can do is know where it's at, change its speed, and advance it in some direction. It's very naive. I think that will work well. There's actually a name for what we're doing with this simulation. It's referred to as a Monte Carlo simulation. So what that means is that you program in random parameters and you let them just kind of go, and you see how it results, and you run that about 1 billion times, and you can see, oh, like by giving everybody a speed modifier of 0.25, it meant that nobody won within a couple of minutes. It's a great way of balancing game mechanics, is that you just throw random parameters and you say like which one of these was obviously unbalanced. So anyways, but what we're going to do is we're going to start with here. In this program, I'm just going to create a bike and see if this kind of stuff works. So I'm going to say like Joel is equal to a new bike. And then I'm going to say Joel.speedup, open close, Joel.speedup, open close, and then Joel.advance. And then I just want to print Joel's.location, position. What would we expect to see with Joel.position here? Two? Well, if we did, let's also test Joel.slowdown. So if we ran this now, Python day 3. Cool, 1. So I've sped it up twice, and then I've slowed it down once. We've moved ahead once. We can call advance a couple of more times. So I could call advance after every time I speed up. Then I slow down, and then I advance. So this should put me at 1. Then we speed up again. So this would put me at 3, would be my position. This should slow me down 1. So this should put me at 5 if I print my position out. Oh no, what math did I do wrong? 1, 2, 3. Slow down. Oh, it would be 1. So that would put me at 4. So, okay, so the math checks out. But you see how that worked? It kind of like snowballed up. Like after I sped up and then I moved forward, it moved another 4, or it moved another 2 ticks with this one. So here. Can you foresee anything that might cause a problem for? Like if our race is only 100 units long, and somebody,
Probably want to limit how fast they can go.
we probably want a speed limit because we don't want them to hit 14 and then be done with the race in like 2 ticks. We probably want to keep them closer to like a speed of 1 to 5. Otherwise, our races will be over very quickly. All right. Well, that's cool. That worked out well. We're done with the bike for now. So now what I want to do with the race is that I want to build the race so that it will create a bike and it will move it forward until it crosses the finish line. Should I create a new file for my bike and my race so that we're not like scrolling up and down trying to go? How would you like to see that? Don't care? It's up to me. Let's do that. Let's make a new file. We'll call it bikerace.py. Because these are going to start spiraling out of control here. So I'm just going to cut my bike, put it into bike race, and then I'm going to import it in. I'm going to say from bike race import bike. That was easy. Everything should still work. Everything does work. All right, so I'm going to go ahead and define my race here now. I'm going to define it below bike because race requires a bike to exist, so we're going to have to define it above. We're going to do that. So we're going to say class of race, and we're going to do pass. So let's think of it like this. Now here's something interesting to think about. If you have a race that requires a bike, but a bike is defined in another file, would where you put your import matter? So like if I have, just for an example, I'm going to roll this back, so don't follow along with me. So if I make bike.py and I move bike into here, and let's say I need to have, I say self.bike is equal to bike. Would it matter if I say from bike import bike like this down here below? What do you think? What's your intuition tell you?
Sorry, aesthetic.
Will this work?
No, because you're trying to create a bike before you import it.
Bike isn't global, so it should come before the class race, right?
Well, so this is kind of an interesting thing, is that this will work because it is within the class constructor. And so by the time that this constructor is actually ran by my program, everything has had a chance to import. But this won't work if I try to do this here. If I try to make a bike right here in my class definition file, that will not work because it is above, as John said, it is above the import. But this is one of those things to look out for, is that your import is below here, but we've defined it to be used up here. With that said, all of your imports go at the top of the file. Don't even play. It will alleviate 90% of those pain points. Sometimes you might see me put my imports not at the top of the file, like yesterday. I had some imports down here. That was okay because I was just using them below here. But best practice is to always keep your imports all up together, up here at the top of your file. If you're ever curious, if you're ever wondering. All right, so I'm going to move that back. Like I said, don't follow along with what I was doing there, because
On that last page, do you have to individually import all those, or do you like import all of them in one file? Just to have it cleaner, like copy and all that other stuff on the other file.
oh yeah.
Those are all just Python things, right?
Right, you would be able to say import random copy OS. You can do that. I try to put them on different lines though, because it can be difficult. Like if you want to take one out, then you wind up like playing the minefield of the selector, and like then it selects everything, and so it's sometimes better just to like say, you know what, gone. But yeah, you can absolutely do that. You can also do multiple imports, like import bike, race, fun time. Like that's usually fine to do. You'll see me do that a lot in like week 4. So sometimes that's what you have to do. Okay, so let's clean some stuff up here. I don't even want this bike.py, so I'm going to delete it. Like I said, don't follow along with me on that one. There we go. All right, so I've got a bike, I've got a race. I know that this bike here isn't going to stay like that because a race is going to have multiple bikes. But for now, for the game logic, really I want to build out the interface of how I use the race. I'm going to build out the methods, and then those methods are going to do what they have to do so that my bikesim.py program isn't going to change at all. Like ultimately what I want to do is to say, whoops, why did that do that? I want to say race, or let's say, you know what, we're jumping way too far ahead, so I'm not even going to code that out. Let's go back to here with the race. So what are the other things that I need for my race? I need to have many bikes. Well, we've got one. That's good enough to get started. I need to know how long the race is. Okay. So that's a data point. And I store that data point as an integer. Because we're thinking kind of low level and abstract here. I'm not going to load in some graphics and do all sorts of weird programming for that. Like we're thinking very abstract numbers, things representing a simulation. Kind of like we were programming in the early 80s. So I need to know how long a race is. So I'm going to say self.length, and we can default that to 100. But eventually I might want to pass that in. Say like, you know what, this is going to be a longer race. Let's see if an endurance race changes any of the fact of the random modifiers. We need to be able to advance all bikes. Okay? So that's going to be a method that just increases or tells a bike to advance, right? So let's make a method here that will, let's call it advance all bikes. And right now we just have self.bike, so I'm going to say self.bike.advance. Before we go any farther, though, I'm going to stop there. Not for break, but I just want to stop there for discussion. Why can I call advance on a bike here?
Self.bike is now an object bike, which has a method advance.
Right, it is a collaborator. So this race has a bike that it has full access to all of the methods and data points on it. So that allows us, so we could here on race call speed up or slow down. But I'm not going to do that. I'm going to let the bike be in control of that. So we have this bike.advance, and that's going to set its position plus equal to self.speed. Advance all bikes. And then I want to make a method. Let's see. That says advance all bikes, declare a winner. Okay. So in order to declare a winner, I probably need to see if there is a winner. And a winner is what would define a winner in this bike race's from its perspective?
Bike's position equal to or greater than or equal to the race length.
All right, so if a bike's position is greater than or equal to the length, we want to stop the program. So what I'm going to do is I'm going to call this method, we'll call it start. Start your engines. And I'm going to do a while true. I'm going to do a while loop in here. And I want to call advance all bikes until a bike position is less than or is greater than or equal to dot length. So while true, I want to say self.advance all bikes. And then I'm going to say if self.bike.position is greater than or equal to self.length, I want to break.
So self.advance all bikes is what you're doing while the statement is true.
Yes. Yeah. So that is going to say that the first time it comes through here, it's going to say I want to move all bikes forward. And then after it moves all the bikes forward, well, in this case, it's just going to move the one bike. But after it moves the one bike forward, it's going to say, hey, is that bike's position farther than the length? If it's not, we want it to advance again. And we want it to advance until it's greater than or equal to the length of the race. And then when it is, we want to break out of the while loop. We want to say stop looping. Now, this is going to get more and more complex, but I just kind of want to show how we scaffold out the basic bare bones of the program. After we come back from our break, we will then make this actually work. Because what's going to happen is that I'm going to come over here, I'm going to erase all this code, and I'm going to create a race. So let's say my_race is equal to a race, which I need to import here. So I'm going to say bike and race. And then I'm going to say my_race.start. So, anybody have any hypothesis of what will happen when I run this program? John, will it error out on me?
It'll be an infinite loop.
Why will it be an infinite loop?
Well, yeah, because we don't have the bike set to speed up anywhere. Because it will call advance all bikes, which will tell the bike to advance, but advance just this position plus speed. We don't have to actually speed up anywhere.
Right, because the speed is 0. So when we run this, it's just going to sit there. We basically said go, and the bike is sitting there at the starting line because nobody ever told that racer to speed up. So we need to tell the racer to speed up. So we just say in advance, maybe we say self.speedup. Now when we run it, it's done. Yay.
Of course, that's, well, we got a ramp.
We do. We have a bit of work ahead of us, but we know that since the program ended, it didn't tell us anything. But the only way that that program was going to end is if I manually killed it or if a bike's position was greater than the length. Effectively saying somebody crossed the finish line. So what we're going to do when we come back from our short little break here is we're going to get a little bit more reporting so that we know how fast the bike was going, what its final location was. We're going to fix some of the bugs that we've created because right now we have just put very little logic in here, and we made an assumption that every time we advance we want to speed up, saying there's no top speed or anything, adding no randomization, so it's going to be very predictable. And then we're going to put more bikes in there. So that's what we're going to do for the remainder of the class when we come back from our break. So see you then.